Okay, so we have learned uh, slightly on the introduction of matrix, the echelon forms, okay, the row operations, okay, and lastly we learn about the determinant. Okay, before we continue on this matrix, I will just start with just some review about Laplace that I think I will need to give you a little bit Laplace and then continue for matrix a little bit, and then the rest will be our review on uh, mostly higher order differential equation as a preparation for your midterm. Okay. Okay. Let me go through what we have here. Let me go through. Wait for a moment. The Dirac delta. I think I will just add from here. I will add some page just to give you that we are going uh, to review some part of the Laplace so that when you read my notes, you understand there will be some additional exercise here. Okay, so for additional operational properties, it should be in the morning session, but I forgot to mention. But let me just start with if we have Laplace. Um, let's say this is t, and then e, uh, say negative tan t. Okay, what will happen? First, we can think that by translation. We can think by translation. So we can think from this e. Okay, so from this e, we know that this will be equal to s minus 10, so plus 10, right? We got this. But then what? What happened here is we have another t, right? We have another t. In our previous sessions, we learned that if we have this, we can solve by taking the derivatives, taking the derivative ddx. Okay, so we know that this can solve through minus ddx of our 1 over s plus 10. So we can get that this will be 1 over s plus 10 squared. Or this is first way using the derivative ddx. Okay. Or if you remember that if we have Laplace of t means that we will have 1 factorial divided by s squared. Okay, and then according to the theorem for that in the translation theorem, that when we have t multiplied with e with power of negative a t or a t, okay, so let me write this, then t, which means that this is practically 1 over, and we can change s with s minus 10, so we are having s plus 10 here, and we got the same result. So we can have from the derivative, or we can have from the translation theorem, which both concepts are true. So in the exam, supposedly you have Laplace, and you can set options whichever you want to apply. Okay? And then another part, um, I think for the differential equation of Laplace, you should be able to do that. Okay. Remember that we have the pattern, right? Have the pattern. Let me check which one that we need to have. Okay, let me. Okay. Okay, if we want to solve the DE using Laplace, okay, maybe start from y prime minus y equal t et sin t. Okay, wait. Okay. And then we have y0 is equal to 0. Okay. Okay. Now, using Laplace means that we are going to have Laplace of y prime minus Laplace of y and Laplace of this t e with power of t sine t. Okay. Okay. Now we start with this. I will define this by the t will be defined with our derivative dds. Later we will define with dds. So I will just focus on what is e power of t sine t. And if you remember that et is basically, we say that this will be related to our translation theorem. So based on translation theorem, remember that the Laplace of sine, this will be resulting in 1 over s squared plus beta squared is 1. Okay, that is our case. And this will be exchanged through e with power of t, so s minus 1 squared plus 1. And so this is our e t sine t. Okay. Okay, now what this means by t et sine t means that this will be the first derivative minus of with respect to s, and we need to derive this. So we can, I think we can just take the quotient rule. So we take s minus 1 squared plus 1 and the whole thing squared, and then 0 minus, so minus 2s minus 1. So we will have 2s minus 1 over, okay, this is for the right side. Now the left side, I'm going to use this, a different color. This will be equal to s ys minus y0. Maybe I will write y as a more curve here to differentiate with the capital Y. And then minus y capital like that. So this will be 0, right? This is 0, so we can cancel this. So we will have ys is s minus 1. Okay, and then the right part is 2s minus 1. And then still we have s minus 1 squared plus 1 squared. And divide by s minus 1, we can cancel this, so we can have our 2 x squared and then this is basically we can get from, this is 2, so we need to take the inverse, so we need to take 2 s minus 1 squared plus 1 and then s minus 1 squared plus 1. Okay. Okay. And then what will happen here? This is basically we are having the sign, right? The sign. So remember the sign is having a constant. So maybe we can take this as our subject. So one of it, this will be equal to e t sine t, right? And the other part, okay, the other part will be, if you remember, if we take this s and we have another s down there, that will be going to be plus or even minus using the this t e t cosine t. Okay, you can confirm this with your own calculation whether this is correct or not. But if you think from just the left one, is I think it's correct. Okay, I'll just give you your calculation. Okay, and let me just go through convolution. This is just a small review. A small review. Okay, now the next thing on Laplace is convolution, right? Convolution. Let me just give you some example. Some example on convolutions is Laplace of t squared convoluted with t e with power of t. Okay. This we can write Laplace of the t squared multiplied with Laplace of t e t. Okay. So this Laplace will be 2 factorial, right? S cubed, and then multiply with t e t. We can start with a with, if we want to use differentials, a derivative, we take negative DDS of 1 over S minus 1, right? S minus 1. And take derivative, this will be result in 1 over S minus 1 squared, right? Positive. So we will have, this is 1 over S minus 1 squared, and this will result in, if we write in more clear way, this is what we have. Okay. And same way, we have another one. Let's say we have e with power of 2t convoluted with sine t. This is Laplace of e with power of 2t and multiply with Laplace of sine. E with power of 2t is 1 over s minus 2, and the sine t is 1 over s squared plus t, or we can just say that we have s minus 2 s squared plus t. Okay, this is just looking at the convolution. And what else? That is, I think, a typical question. If we have the Laplace, for example, Laplace, but inside is integral. For example, start with e with power of tau. Remember that this will be giving you 1 over s, and then this is supposed to be fs, right? Fs from here is just a Laplace of e with power of t, and this will be giving you 1 over s minus 1. Okay. Okay. Okay, I think that's just a small reminder on Laplace, the convolution, and the derivative when we have, especially the derivative when we have this t and then functions, and t and then functions, means that we are going to translate. If we have Laplace, for example, we have t squared e negative tan t for this part. Then we need to differentiate twice. So this t is, the power is giving you the clue on how many derivatives you will be doing. Okay, this means that you will going through this okay. So twice derivative, and don't forget, whenever you have just one, okay, just one, you have negative. Okay, so any odd nth order derivative, you'll be having the negative in the front. If you have even, like second derivative, fourth derivative, it's positive. Okay. Okay, I think that's just small review on additional operational property, and how to solve differential equation using Laplace, and also the convolution. Okay. Okay, next is, we will go a little bit on matrix, and then we will have a review. Okay. I will just finish off the we have learned the augmented matrix, the homogeneous system, and we have the superposition principle also in matrix for the solutions, and then we have the determinants. Okay, determinants. So we have 2 by 2 matrix, 3 by 3 matrix. Okay. 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 Determinant of transpose. So if A transpose is transpose of n by n matrix, then determinant of A transpose is equal to determinant A. So it's just the same. Because remember, the transpose, you are changing row to column, column to row, and basically, if we are having the determinant, maybe we start with the 2 by 2. If we just exchange and we are doing the determinant, it will be the same result, right? Same result. And then another property is if any rows or columns of n by n matrix the same, if they have the same, then determinant of that matrix will be 0. And if all n3 is 0, this also gives that determinant of that matrix will be equal to 0. All entries in row, or column. Okay, I think we can also have determinant AB is determinant A multiplied with determinant B. Okay, what else? If we multiply with scalar, I think we can multiply with scalar with K constant. I think no problem here. Okay, and then I think another part is related to triangular matrix. Triangular matrix. Okay, suppose A is n by n triangular matrix. It can be upper or lower. Then the determinant A is A11, A22 until the A of that nn. Okay. And this A11, A22 until this ANN, this is the main diagonal. Okay, if we have A 3 by 3, let's say we have triangular at the lower part. Let's say we have this. So determinant, if we take determinant this 3 by 3 matrix, so we have A11 multiply the determinant of A220, A32, A33, and the rest will be all 0, right? The rest will be all 0. So we will have A11 and then A22, A33, and the rest is 0. So it's true that this determinant is the diagonal here. And to solve the determinant, we can also reduce the form, okay? And we can make it into triangular form also, and it will be easier for computations. Like this is, I think, good idea, and maybe you can also apply in your calculation that for determinants. So we can call this is the row reduction. So for example, if you take determinant, or maybe let me just write A, matrix A is 6 to 7, -4, -3, 2, 2, 4, 8. Okay, we take the determinant A. We want to calculate, or maybe let me write this with question marks. So determinant A, we can write using the row operators, and we can reduce into triangular form, and then easily calculate the with the diagonal, okay, with the diagonal. Right. So first is we can take factor out from 2, 4, 8. We can factor out 2. We can factor out 2. So we can write 2. We can just write 2 outside here. Still okay. And this become 1, 2, 4. Okay. And then we can have this one, right? I will move this one here, so I will make 1, 1, 1 in the diagonal. So we take that. So we take 1, 2, 4. Oh, sorry. Okay, I think I have to mention. Okay, I forgot to mention. Okay, before we got to the row reduction, let me give you some idea that if P is matrix obtained by interchange any two rows or columns of n by n matrix A. Okay. Then determinant B is negative determinant A. So if A So we interchange any row or any column. You can say that determinant B is equal to, let's say, 2, 1, 3, 6, 0, 7, and 4, negative 1, 9. So if we are having this, it means that this is the negative of our 4, 1, negative 1, 9, 6, 0, 7, and 2, 1, 3. And we call that this is negative determinant A. So when we interchange rows, we are getting the negative forms of that determinant. Okay? So that is what we are going to do. Okay, so row reduction. So row reductions. So we are going to exchange this to. So instead of 2, we have negative 2 outside, okay, because we interchange row. And then we can do the row uh, as row operators like we did before. In matrix, we can a multiple row can be added to another one. Okay, so we can multiple with a scalar and then plus or subtract with another row. Okay, so let's do that. Okay, so we are going to, or maybe let me write this part going to be here to make it easy. So this will be, so for my idea is to get this to be 0. Okay, so what we need to have is for the row 1 is plus to row second row, so negative 2, writing the same first row, and the second row is 4 minus 4 is 0, 8 minus 3 is 5, 16 16 minus or plus, okay, or plus 2, 16 plus 2 is 18. Okay, and then 6 to 7, and then I will make this 6 with 1 subtract to become 0. So let me write this 1, 2, 4, 0, 5, 18. So this will be 6R1 minus R3. 6 minus 6, 0. 2 minus 6, 12 minus 2 is 10. Or maybe 2 minus 12, I will write I think just 6R1 is, I think, okay. 6R1, so 6 by 2 is 12, minus 2 is 10. 24 minus 7 is 17. And then the next part is 0, 5, 18. Now the next part, we are going to take this to be 0. So 2R2 minus R3. So 0, 10 minus 10 is 0. Last one, 36 minus 17 is 19. Okay. Now, what will happen here is our determinant is this, right? Based on what we have in triangular matrix. So determinant A is -2 multiply 1, 5, 19. Okay. Or we could just write so multiply -2, 5, 10, 190. So -190. Okay, so another way to solve the determinants, aside using the directly formulation for determinants, you can take these row operators also in the matrix. Okay, but remember, whenever you interchange the row, whenever you exchange the row 1 to row 2, or row 2 to row 3, or row 3 to row 1, if you change the row, you're having the negative form of the determinant itself. Okay. Okay, so determinant. So usually, what the determinant is used for? Usually, it's used for finding the inverse of the matrix. Okay, usually that is one way to see. But let's just see what is the inverse of matrix. Okay, so this is row reduction. Okay, so if we are going to look at the matrix as it's in inverse. Okay. So remember that if we have the matrix A and matrix B, okay, this will be not the same as B going to A. But if this matrix both are inverses, then let's say A is n by n matrix. Okay, wait. Okay, let's say A by n, and then exists the not exists. There exists, okay, n by n matrix B such that okay, wait. Okay. So there exists matrix B such that A B equal B A equals its matrix identity. So this is matrix identity, n by n identity. This is said that conclusion here is the A is non-singular or invertible. And we can say that B is said to be inverse of A. Okay. So first the definition. Okay. So A inverse. If we inverse again, this will be going to be A, some simple property. If you have A, B, and you want to inverse after multiplication, this will be resulting this. And if you have A transpose and inverse, this will be, we can inverse first and then transpose. Same result. Okay, I don't think proving this will be useful, but this is practically the some property on the inverse. Okay. Another important method in the inverse is we call the adjoined method. So let A be n by n matrix. That is transpose of covectors correspond to entries of A. So we call that, let's say we have C11, C12. So we transpose this, and this will be C11, C21. So this is called adjoint of A, or we call adjoint A. Now from this adjoint and some, I think we can take this. Oh, sorry. Make more in one page. I will make it in one page so you can see the. So A inverse matrix, inverse of matrix A. So let A be n by n matrix. So row and column should be equal, okay, n by n matrix. And if determinant A is not 0, then A inverse, we can define this as 1 over determinant A and multiply with the adjoint of A. Okay, remember that since adjoint has the cofactors, and cofactors means that when you are having your determinants, remember you have plus minus, that is the cofactor signs. Okay? So whenever you have this, you need to add your negative signs later. Let me just give you a simple 2 by 2 matrix to see the inverse. Okay, let's just start with if A is A11, A21, A12, A22. The covectors, if you want to make the covectors, this is simply just say A22. So, or maybe you can write the transpose first. You can write the transpose, which becomes A11, A21, A12, A22. So adjoint, if you remember, adjoint, we need to take the uh, oh wait, I think I missed something. Okay, I think we can write here. Right, maybe using the C11 first, and then C12 will be negative A21, C21 will be negative A12, and C22 will be A11 because we are going to take the adjoint A, C11, C21, C12, C22, and transpose this, and this will be A22, negative A21, negative A12, A11, 1. Transpose, so A22, negative A, negative A21, A11. So A inverse, matrix of A, the inverse of A, is 1 over determinant A multiply with this A22 . Well, since it's 2 by 2, I think it's still okay if you are maybe if you are having a little bit I think determinant it should be still okay, and if you calculate the determinant is just the if A usually this is what you have in high school, right? Determinant is AD minus BC. So if you write wrong in this A and D, I think still the same results for determinant. So to give you a summary of what is in the practical use in example, if you have A, let's just start with the 2 by 2 matrix. Okay, 2 by 2 matrix. We take the determinant. This is 10 minus 8, which is 2. So we can take the inverse 1 over 2 and then the adjoint. So adjoint means that we are having for 2 by 2, just exchange this 1 to 10 and take negative to the rest of the number. So first we can take this 10, 1 and then negative 2, negative 4, and then we can just multiply with half. This will be 5, negative 2, negative 1 and half. Okay. If you want to check whether this is true or not, we can check the A multiplied with A inverse. Okay, we can check. So 5 minus 4 is 1, and 10 minus 10 is 0, and the negative 2 plus 2 is 0, and negative 4 plus 5 is 1. So it's identity matrix, so it's our inverse. Okay. Now for 3 by 3 matrix, okay, for 3 by 3 matrix, the A inverse is 1 over determinant A Okay, that's the for the third 3 by 3. So if we have example 3 by 3, 2 minus 2, 3, 2, 0, 1, 1, 0, 1. Okay, I have another method for finding matrix or inverse of matrix, not using any determinant or any using adjoint. We can use the row operations, the echelon form, but I think I will give you maybe next week if we still have the matrix. Okay, first finding the covectors. Okay, finding the covectors. Now for 3 by 3, we need to really consider the covectors. For 2 by 2, we just simply exchange this 1, right? And then adding negative. That's just the 2 by 2. Easy to follow, right? But for the 3 by 3, you need to be careful and looking at one by one. C11 is going to be determinant of the covectors is going to be here, right? 1 1 and 1 1 0 1 1, right? Or let me write completely. So this will be 1, and then C 1 2. So we are going to have 2 0 0 1, and this should be negative, having negative. Okay. Remember, it is positive, negative, positive, positive, positive. So this will be negative 2. And then C1 3. C1 3 is 2 0 1 1. So it's also 2. and doing all the same here, we got that we need to check the determinant first, right? Determinant A using the there is another way that I think you can also use this. 2, 2, 0, negative 2, 1, 1, 3, 0, 1. And I will add another one here. The first two here, I will write again 2, 2, negative 2, 1, 3, 0. This is if you want to skip some time to calculate. This is one method that I find maybe faster than usual. So you can just multiply, 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 and add. So let me add 2 plus 6 plus 0. Okay, and then minus another one, multiply here, and adding all. Okay, so it's the first two is 0, the last one is negative 4. So it will be 8 plus 4 is 12. And if you using the same method, using the determinant, the cofactors, it's also the same 12. Okay, so 1 over 12. So the A inverse is 1 over 12. And then supposed to be 1, negative 2, 2, and then later you will have wait. It's supposed to be transpose, right? This is transpose, right? Yeah. And then the rest you can find here, and that will be your inverse, your matrix A. Okay. Okay, last part for the matrix, and then we can have our review for the midterm. Last part is finding the inverse through row operations. Okay. So let me write row operations to find inverse. Okay, so basically the procedure, suppose A is a non-singular matrix. Okay. Now, if we have A, okay, if we have multiply with the identity, we have A, right? Now, if we multiply with the inverse here, and we have multiplied the inverse here, this should be equal to identity, right? So identity, and make it an identity. So let me write here. So what we have here is actually when we multiply this is the same thing as we say multiplying the identity with A inverse. What is really going on actually? So practically we are going to see this AI. So let's say, let me give you just practical example. So let me just give numbers. Okay. Now the identity for 3 by 3, we know that the 3 by 3, 2, 0, 1. Let me write here. Negative 5, 5, 6. The identity for 3 by 3 is 1, 1, 1, and then 0, 0, 0, 0, 0, right? Okay, what is our goal? What is our goal? Our goal is to make the left part here, make it into 1, 1, 1, 0, 0, 0. Okay? But we take this in terms of row operators. So this will be row 1, row 2, row 3, as we previously used. Okay? So we are going to subtract, add, multiply with scalars, and then add, multiply. Maybe we divide. Okay. The idea is to make the left side 1, 1, 1, and all 0, the identity matrix, and the one that will be in on the right side, this will be our inverse. Okay. And in some way, if you can see some numbers, if it's like easy to calculate and quickly, this will be very fast. This is a very, very efficient and effective method to find the A inverse. Okay. So if we want to try this, then we could try first. Okay. If you see this, the first idea, maybe taking these 2 and then divide all the row 1 with 2. Okay, let's just divide that. So we can write this becoming 1, 0, half, and then half, 0, 0. The rest still the same. And you can start from anywhere you want, as long as you keep consistent, no mistake in calculations, and all row can be rearranged as 1, 1, 1 as identity, and on the left and on the right will be your inverse. Okay. Okay, what next here? The next thing is we are going to look at the deal is I want to make first is maybe this negative 2 make it 0. So maybe I will multiply the R1 with 2 and then plus the R2. Okay, so let's do that. So 1, 0, half, still, half, 0, 0. And then the second part, this is 0, 0, 3, 1 plus 4 is 5. And then we have 1 here. It's become 1. Oh, sorry. Oh, if the charge. Forget. Okay, maybe 5 minutes break. Okay, 5 minutes break, and when we got back, I will continue a little bit and move to our evaluation or reviewing. Okay. Okay. So we can continue. Okay. Now we fill in the second row. 2R1 is 1 plus R2 is 1. And this is 1. And this is 0. Okay. Now the third row, I will directly want to change the third row by looking at this. And I will make this 0 with 1 here. So I will make this 5R1. Okay, and then plus R3. Okay, for the third row. So this will be 5 minus 5 is 0. 0 plus 5 is 5, right? And then half become 5 over 2 plus 6. 6 is 12 over 2. So 12 plus 5 is 17. So 17 over 2. And 5 over 2. And then 0 and then 1. Okay, now I want to make this divide by 3, divide by 5. So let's do that. So make it 1 over 3 R2 and 1 over 5 R3. So same. And this is 1 over 3, 1 over 3, 0. And then 0, 1, and then this will be 17 over 10. Okay. 5 over 10 is 1 over 2. 1 over 2. And then 1 over 5. Okay, what else we can do is we can make this 1, 0. Just subtract this 2. Okay, I think we can make R3 minus R2. Okay, so 0 minus 0, 0, 0. 17 over 10 minus 5 over 3. Okay, so 51 divided by 51 minus 50 is 1 over 30, right? 1 over 30. Half minus 1 over 3 is 1 over 6. Minus 1 over 3, 1 over 5. Okay, let me take here and let me take right here. The next thing what we can do is we want to multiply this with 30 to make it 1. So multiply 30 R3. Well, you need to be consider how fast you can write and calculate. This can be really effective if you can choose correct numbers and correct way to find the operations. Right? 30 is 5, 6. And then the last part is taking this to be 0. So I will write R1 minus half R3. Okay. And then the second one is R2 minus 5/3 R3. So let's do that. So 1 R1 minus 1/2 R3. So it will be 0, 0. And half minus 5/2 is negative 4/2 or negative 2. And 0 minus 10 is 5. So it's 5. And 0 minus 6/2 is negative 3. So that's for the first row. The second row, that we are going to change the second row. 0, 1, 5/3, 5/3 is 0. 1/3 minus 25/3. So 25 minus 1 is 24/3 is 8, negative 8. Okay. And R2, 1/3 minus 50/3. 51 divided by 3 is 17. Okay, I think it's a good number. And lastly, 0 minus 6. 30 divided by 3 is 10, so negative 10. And this is 0, 0, 1, 5, negative 10, 6. Now we already have this, and we can say that this will be the inverse. Okay, this will be the inverse of A. Okay, by the row operation. Of course, if you use the row operations and if you find, okay, if the one that is here getting 0, 0, 0, then it is no inverse. Okay, no inverse. Okay, I think we can move to the preparation for midterm. Okay, I think we can move to the preparation of midterm. Okay, so let me give you these notes first. You can write notes if you want. And let me charge my pencils again, and let me prepare for some practice and exercise. Especially uh, for the higher order differential equations.
Professor, I have
Yes.
a question
Mm-hmm.
about higher order,
Mm-hmm.
like the reducible. The reducible, I saw in your, I mean, I saw in the textbooks they have shortcut methods. Like, can we use the shortcut formula for every question? We cannot.
I think it's still okay. Still okay if you want to use that as well. Uh, but since I think I'm, I think I skipped that one, right, in the notes, right?
Yeah, I think.
Yeah. Because I think uh, but if you believe you can do that by those methods, I think that's still okay because I would keep all of my solutions. We can still solve using beside method. Okay, but if you want to use that method, that's okay for me. That's okay for me. Okay, but I will make sure that all the methods um, that I have told in the lecture, they can be applied. Okay, for all most of the questions. Okay, okay, I think that's the Cauchy-Euler method is, I think, specific for some forms, right, and not all forms. But if you want to use that in some cases in question, I think still okay, still okay.
Okay, thank you, Prof.
Yeah. Okay, I think we can start with um, maybe uh, some of your. Let me check your quiz. Okay. Let me write here review for midterm. Okay, so first, the midterm, we will have at least the intro of differential equation. That is very, very short, just to classify the order, what kind of the equation we have. Okay. Second part is the first order differential equation, which we are having exercised before in quiz and also homework, right? And the third one is the higher order differential equation. Of course, second order is applied in this higher order. Okay. So notice that you have some method and also some of the like, for example, the first or differential equations, we learn the slope field, right? We learn the autonomous, and we learn some method like separable. What else? The linear, right? The linear exact equation and the substitutions and Bernoulli. And the higher part, we have more. Okay, but let me just go for the first order first, and maybe taking from the quiz question. I think most of you not really getting the correct answer with this one. I think few of you get the correct answer. The question is find appropriate integrating factor to solve and to solve the equation, which means integrating factors mean that you need to find what kind of functions that when you apply and then put in the formula, it becomes solvable, so you can solve the equation. So first, integrating factor is defined by, let's say, r, or if you want to use mu, it's okay. So rx is e with power of, usually in the linear we have px dx, right? Usually we have this. But since this seems to be exact equation, but we are not sure if it is exact or not, right? So we can check first. Okay, check. So this is logically you start with from here. So check exactness if you want. But I think you see that clearly you need to partial y here and partial x here, in which it's not the same, it's not exact. So we call this almost exact. So we need to multiply with integrating factor, right? So first, let me write here that this is d, or dou should be partial, dou y of x is 0, and dou x for x squared y plus 4y is 2xy. Okay. Now we see clearly that it's not equal, but we know that in the exact equation, to make it exact, we need to have integrating factor. And integrating factor, as I mentioned, we can define this from here, and it can be defined with m or n according to what kind of function we have at the end. Okay. Now, if we clearly see from here that it's going to be 2xy, right? But then the uh, the one that you need to take care of is, you see that the m is just x. So probably we need to divide by m, right? Because we have 2y. But this is where things getting wrong. Okay? Because if we have 2y, it's not integrating factor. The integrating factor is we have e, and then remember that when we have this, with respect to dy, we need to have the minus 2y dy, right? And then what will happen here is this is getting negative y squared. And you can also try to make sense whether this is true or not, or this is possible or not, to make these equations become exact. Okay, so that's actually the goal of this question. So we need to make sure that this can be solved. Okay, now then, what's happened if we divide by n? So we need to try both. We need to try both and consider which one is true. Okay, so we consider this divide by x squared y plus 4y, and I think we can factor, right? We can factor. So, we can get this. 2x divide x squared plus 4. So probably we can use this. Okay. So e, now 2x divided by x squared plus 4 dx. Now we can just use simple substitutions, and we can cancel this, right? And we can take the 1 over u du, right, and become ln u. Or we can write that that this will be what this is 1 over u. Ln u is let me write this ln x squared plus 4. I think this one should be minus, right? Right, minus. Let me check. Okay, let me check, and maybe check with your equations, just to make sure that I wrote the correct one in the notes. Okay, Laplace. Where is it? Oh, here. Oh yeah. So it's correct. Oh, I think I know. This is supposed to be negative. Sorry. Forget the negative. So it's negative. Okay. Okay, so e with power of negative ln, we can write e ln x squared plus 4 negative 1, and we can say that this is x squared plus 4, and this is the answer, the integrating factor. We can check and we can argue that this is correct, so you can apply to our solution. Okay, if you want, you can check. You can check and do some partials to make it to make the solution from it. But that's not important. But I think just to make sure that it's exact equation and it's solvable and it's the integrating factor. Okay. So that's the from the quiz. I think another oh, another notes that I want to make sure is another notes that we have if we have this autonomous equation. Okay. Now, first is define our critical points. Critical points before we set up all the asymptote characteristic. So y is -3, y is plus minus 2, right? So -2 and 2. And then we can set the portrait, the phase portrait. So let's say this is 2, this is -2, -3. Okay. Now what we can do is we are going to check from this interval when the uh, the the portrait becomes attracted and becomes repelled. Okay, we can check with this interval. So we can first we can maybe going for around here, which is I think we can try 0 and check 0 here, 0 here. We see that this is becomes negative, right? It's become negative. So if negative, we write going down like that. And maybe we take the positive here, maybe 3. Okay? We take 3, this is positive. We take 3, this is still positive. So if positive means going down. And then in between here, we can take -5/2 or -2.5, 2.5. Okay, -2.5. If we plus 3, it's negative, but it's squared, so it's positive. Okay, and -2.5 squared has become positive, but -4. So we can take that as let me just write 25/4 minus 24 16/4. So it's a positive. Okay, it's positive. And then take negative, let's say -4. Let's take -4. -4 here is positive, right? It's positive. -4 here is positive. -4 is still positive. So it's going to be up. So whenever you have positive, you take the upwards arrow, and whenever you have negative, you take downwards arrow. So when we have going up, this part will be semi-stable. Okay. And if we have going down and going up here, this -2 becomes stable. And this is if it is repel each other, this become unstable. Okay. Easy, right? Easy. Okay. I hope you can get this correct. Okay. In the midterm. Okay. The next part. Let me check.
Wait, Professor, can I note it down first?
Yeah. Sure. I'll just check here.
So we to check critical points, we just set the equation equal to 0,
Yes,
right?
yes, yes, yes.
Okay.
Mhm.
Thank you.
Okay, and then the rest of the first linear is going to be having the separable linear substitutions, Bernoulli exact equation, and I believe you need to. I think you're already familiar. So I think what we can check is we can check the higher order. The higher order. So let me go through. Okay. Okay, now we take step to higher order. I will just give you quick questions. Okay, quick questions. So let me. I will take. So let's say solve y cube, and not cube. It's derivative, third derivative. Sorry, plus 10y double prime plus 25 y prime. Okay, let's start from the simple. Okay, now we have the homogeneous. We say that this is linear equations with constant coefficients. What we are going to do first is we are going to make auxiliary equations. Okay. And remember, when we're doing the auxiliary equation, we consider that one possible solutions or one possible solutions for the differential to make it this to become zero is we have the exponent, right? Exponent inside, and we can factor out the exponent because if we differentiate several times, we will see the same original exponent, right? So we can uh, factor out this exponent and we can have our polynomials, right? So basically, what we are going to do is this can be made into, let's say, m. You can use any variable, okay, for the equation, but I will just use m, and then plus 10m squared, and then plus 25m. And then this is, and we'll see the for this homogeneous, we can see that we can solve the and finding the roots, right? We can finding the roots. So m, and then this m will be plus 5, right? So m equals 0, m1, okay, m2 is negative 5, and m3 also negative 5. Okay, we can propose our solutions. So solution, we can propose that because m is 0, so there will be no exponent, or exponent with power of 0, it's just 1, right? So it's just c1 plus c2e with power of negative 5x. Okay, now remember, if we have the same repeated roots, we need to use the multiply with x, okay? Multiply with x, so plus c3 multiply with x, x e power of negative 5x, and this will be our solution. Okay. if you have perfect different roots for each m, then you can just write as it is. Okay, no need to multiply with x. Another case is if we have the imaginary number. Okay, so let me just give you I think the easiest one, simple one. Maybe just giving you the question down here. Solve y double prime minus 2y prime minus 2 minus 2y, right? Okay, minus y equal to 0. Okay, again, in this case, we can use auxiliary equations to analyze. Okay, so m squared minus 2m minus 2. I think we can solve this not using imaginary number. I wrote the wrong equation, but let me just solve this first. Okay. So we can have m, just a reminder, you can complete the square. So this will be plus 1, right? Should be plus 1. So to make it negative 2, we need to minus 3, right? So this will equal 0. So m minus 1 squared is 3. So m minus 1 is plus minus square root of 3. So m1 is negative 1 plus square root of 3. m2 is negative 1 negative square root of 3. And this is not repeated root, so we can write the solution. Y is C1E. Oh, it is positive, sorry. E1 plus square root of 3x plus C2 E1 minus square root of 3x. Okay. Okay. Let me continue. Next is 2y double prime plus 2y prime plus 3y equals 0. Again, so this can be done by taking the auxiliary equation Okay, if you feel confused on how to find the roots, you can just go through the formula. So let me just write minus b squared minus 4ac divided by 2a. plus minus. This will be 4 minus 4, 2, and 3. This will be 4. So negative 2 plus minus. This is 8. 8 plus, sorry, 6, 4, 24. 24, negative 20. Negative 20 or 4, and then minus 5, right? Multiply by minus 5. So this will be divided by 4. Okay, I think we can write negative half plus minus. This will be divided by 2. This is square root of 5i, right? Okay. Now, since we have the imaginary number, and we know that we have, this is the alpha, this is the beta, right? Then we can write the solution. E with power of the alpha x, and then multiply with, actually this is supposed to be c1 cosine plus ct cosine, but I will factorize this e outside here. So we can write c1 cosine squared of over 5 over 2x plus sine squared over 5 2x. Okay. Okay. Okay, that's the solution. Yeah, cannot be square root, but if we think on imaginary number, we can. Okay, remember, in the higher order differential equation, especially in this case, we need to consider this imaginary number. We need to consider the imaginary number, and the key words for transforming this imaginary number into this equation is using the Euler equation. Okay. Okay. Mm-hmm. Okay, it's from here. This 5 minus 5 is from here. This is 4. Yes, 20. So this is minus 24 is negative 20, right? So negative 20 is 4 multiplied with 10. Yeah, okay. And then, what else? Okay, 21. Let me consider another method. Okay. Okay. I think we can go.
Professor,
Yes.
I have one. Just wanna make it clear again,
Mhm.
like on the stable, unstable, and semi-stable.
Mhm.
After we find the critical point, and
Mhm.
after that, we have to check, right? Use the critical point to check. I mean,
Yeah, the
like,
interval. Yeah, check the interval.
I'll check the interval. Okay,
Mhm.
okay. Thank you,
So
thank you.
in between this point, what is happening? It is positive. It is negative. If it's positive, you go the arrow going up. If it's negative, the arrow going down.
Okay, thank you. I understand. Thank you very much, Professor.
Okay, uh, next type of questions for the higher order differential equations that we might have is, let's say we have this y double prime plus 2y prime equal 2x plus 5 minus e with power of negative 2x. Okay, now we are moving to this is what we call the undetermined coefficient. Okay, but to write the complete solution, what you need to do is basically you need to consider the homogeneous version. Okay? You need to find the homogeneous solution first. Okay? How to find the homogeneous solution is precisely the same thing as we did here, using the auxiliary equation. Okay? Find that first and see how it can be your solution. And then we need to find the non-homogeneous solutions. Okay? The non-homogeneous we can call, the name is yp. So usually we write the complete solution as y equal yc plus yp. This is we call the complementary. This is we get from homogeneous. And this is the particular solution. This is from non-homogeneity. We cannot say that this is the right one here is non-homogeneous, because then the non-homogeneous is this one is non-homogeneous, right? We just say that the non-homogeneous solution inside of it will have apart from homogeneous and apart from the particular solution. Okay. Now, since we need to check the homogeneous, then we need to check, we need to check the homogeneous one. So this is the first thing we can do. So first, take the auxiliary equation, which is uh, we can take that. So m is 0 and m is 2. for m1, m2. Okay. Oh, it's not 2, sorry, -2. So our complementary solution is we will have C1 plus C2e -2x, right? Okay. I think clear from here, right? So first we get this. Okay. Now what's the next step? Next step is we are going to propose our YP, or particular solution. How do we know YP? We are going to see what is happening in this right side. Okay. We have, let me just confirm that we have 2x plus 5 plus e with power of -2x. Okay, now remember, I think I already give you some table. If you have this kind of coefficient, what will be your proposed solution is we are going to have, since this is linear equations, we will have a polynomial degree 2. We have the quadratic equation here. Okay, and then the last part, let me just write here, we have this quadratic one, and then the last part we have this e. It's supposed to be using the same structure with -2x like this, but since we have this, be careful, this is a duplication, right? So this part here needs to be multiplied with x. And this will be our proposed solution. Okay, what will happen here, then we need to check. So first, checking the differential, and we need to substitute later into our equation. So check the derivative. And derive this. If it's c, c, so let me write here x e -2x. This will be e -2x plus x e -2x with -2, so we write with -2 in front here. So we can write e -2x minus 2x e -2x. Okay, and then, oh, we need to differentiate one more because we have second derivative. So 2a plus, still c, this is -2e -2x, and this is precisely the same, so we will write e -2x, -2x, e -2x. Okay, maybe write one by one, and let's see if we can solve some equations. So this will be -2e -2x plus 4x e -2x. This will be -4 e -2x plus 4x e -2x, and this will be equal to c, multiply with c. Okay, y double prime plus 2y prime. Okay, so this, okay, yp prime plus yp 2yp prime. Okay, this is equal to a plus -4 e -2xc plus 4x e negative 2x c. Okay, and then plus 2, so plus or let me write here 4ax plus 2b plus 2e negative 2xc, and then minus 4x e negative 2xc, and then plus these two. Okay. Can we cancel? I think we can cancel this part, right? Okay, so we will have 4ax plus 2a plus 2b, and then minus 2e negative 2xc. Okay, we have that. Let me copy and write here. So this is our results, and then this should be equal to 2x plus 5 minus e negative 2x. So we need to make equaling both sides. So 4a equal to a equal half, okay? And then 2a plus 2b equal 5. So 1 plus 2b is 5. So 2b is 4 and b is 2. And then negative 2c is negative 1. So c is 1 over 2. Okay. Now yp is then, using the same here, we change all a, b, c with our constant, is half x squared plus 2x plus half x e negative 2x. So our solution, total solutions, is c1 plus c2 e negative 2x plus half x squared plus 2x plus half x e negative 2x. Okay, it's a little bit long and tedious, but actually as long as you can propose what kind of solution we have, if we have the right side, this kind of equation. Okay, so if we have good proposals here, when we are dealing with this equaling situation here, we will get the perfect answer. Okay, so that's what the key is, to find this equation here, the proposal. So to find this yp, this is the key. Okay, a key for this undetermined coefficient. Okay, any questions? Any questions from here?
Professor,
Yes.
if it's duplicate, we have to add x only, or it depends on the equation? Like,
It depends on the equation. For example, we have the duplication on this, right? We have duplication on this. So whenever you find that our proposal having the same structure, so if this not duplicate, we can write like this. Okay, we can just write this. But since it's duplicate, we need to multiply with x. But if we have, for example, we have here maybe the forms of the yc is maybe having c1e negative 2x plus c2x e negative 2x. So we have both here, both cases here. So what can we write here? We can write x squared. And the same thing if you have another duplication, you can write x cubed and so on. Okay. I hope that's clear. Okay. 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 So careful for duplication. Check your especially from your homogeneous one. So that's why it's important to check the homogeneous one and then check the particular solution. It's
Thank
always
you.
right from the homogeneous. Okay. Okay. Good question, then. Okay. Any other question? Any other questions? So maybe we have one more, and then we can have another sections. The method, the other method. Okay, I will give you one more example and maybe some tips, okay, or maybe just some clue. Okay, some clue. Okay. Okay. Give you another questions. Hmm. Okay. Okay. We have y double prime plus 2y prime plus 1 equal to sine x plus 3 cosine 2x. So again, we start to look at this equation, and before we try to find a particular solution, always start with the auxiliary equation. So we take this m squared plus 2m plus 1 equals 0. And we say that this is actually this, right? Same thing, right? Plus, right? So we say that m1 equal m2 equal negative 1. So we have the repeated factor or repeated roots. So our yc is c1e negative x plus c2e, supposed to be e negative x, but we have duplication, we need to multiply with x. Okay. So first we get this complementary solution, okay, from homogeneous. Okay, now how do we write our particular solution? So since we have two trigonometric, okay, so if we just have sine, if we have just sine here, we can write the sine is a cos x plus b sine x. But since we have another cosine here, then we need to add. We need to add plus c cosine 2x plus d sine 2x. Okay, so we have four components. So our proposed yp is a cosine x plus b sine x plus c cosine 2x plus d sine 2x. Okay. We need to substitute into our differential equation. So we need to first differentiate one time. And then this will be negative 2 c cosine sine, and then plus 2 d cosine 2x, and then another one, four cosine 2x. This will be negative 4. Okay. Now we need to multiply this by 2 and then add. So add all. Notice that we can have a cos, negative a cos, b sine, negative b sine, right? So we can cancel this. And then we can calculate, so y double prime plus 2y prime plus y. Okay, so my preference, I always writing like this so I can exchange and rearrange more easy rather than horizontal. So if you make this horizontal from the left to the right, it's really long, right? It's really long, and maybe you cannot see the variables, right? The variables. Okay. So negative 3c cosine 2x and negative 3d sine 2x. I will write this one first, and then write the middle one. Minus 2a sine x plus 2b cos x. Maybe let me write minus 4c sine 2x plus 4d cos 2x. Okay. Now the idea is to combine or regroup. So cos 2x is 4d minus 3c, right? And then plus sine 2x is sine 2x is negative 4c and negative 3d, and plus cosine x. Cosine x is just the 2b, and sine x is just negative 2x. Okay, we have here we need to equal this. Okay, equal this. Let me resize a little bit. Equal to sine x plus 3 cos 2x. Okay. So 4d minus 3c is equal 3. And then negative 2a is equal 1, so a is negative 1 over 2. And 2b is 0, so b is 0. And what else? Oh, negative 3d, negative 4c is 0. I think we can solve this by taking to 4 and taking to 3. So we have 16d minus 12c, 12, negative 9d, negative 12c equal to 0. So negative 25d equal 12. So d is 12 over 25. So of 48 over 25, negative 3c is 3. So 3c is right. And then we get 75. It's 27, right? 27. Okay, we got that. So we get all crucials constant. So yp, where is yp? Oh, a cos x. A is negative 1 over 2 cos x, 0, and then c 12 over 25 sine 2x. Okay, this is our solution for the particular solution. So general solution. Okay, okay, I will write e with power negative x outside. So c1 plus c2x minus minus half cos x minus 9 over 25 cosine 2x plus 12 over 25 sine 2x. So this is solution. Okay. Okay, so let me give you some quick look at, okay, if we have combinations between this function. Okay. We are not necessarily solving, but let me just give you a quick recap. Okay. So if we have y double prime, e to the x multiplied with cosine to x. Okay, not finding solution, but I will just give you what we can do if we see this ex cosine to x. First, maybe finding the homogeneous one. But if we have this, okay, let's consider that we are, maybe we don't know this one, but it can be any differential equation. But what can we do for the particular solutions is cosine to x is basically a cosine to x plus b sine to x, right? And if we add this e to the x, which means that our particular solutions will be a power e x cosine 2x plus b ex sine 2x. But of course, you need to be careful on this ex. It might duplicate with this. So if it's duplicate, then need to be changed, right? It need to be changed. Maybe this will be adding x, and this will change probably. But that is just how we can find. I think you can just use the table that I gave you. I think I gave you in the previous lectures when I gave you this method. Okay, you can use that for your reference.
Professor, let's say in this case it's duplicate, so we only put x in only a or b, right? And any right, just a or b, but not two of it.
Two of it, two of it.
Two of it.
Yeah,
Okay. I
because
got it.
it has cos and sine, it will be not duplicate, right?
Oh yeah, I got
Yeah.
it.
Okay.
Thank you.
Okay, now I'm giving you a new directions for the variation of parameter. Okay. Okay. Um, let me give you y double prime. Okay. When you see this, we can use the undetermined coefficient. Okay. We can use undetermined coefficient, and we see that this is precisely this, right? So we can say that we have maybe polynomial here, ax squared plus bx, and we have the exponent here. Okay. And probably we are having this kind of solution if we want to do using undetermined coefficient. But if we want to use another method, okay, if you want to use another method, we call the variation of parameters. The first step is the same with the previous one. We need to check the homogeneous solution. Okay, so check homogeneous solution. So we are going to use our auxiliary equation, which is getting m squared minus 9 equals 0. So m squared is 9, so m is having plus minus 3. So we have our complementary solution, C1e, let's say 3x, plus C2e negative 3x. Okay. Now from here, we get uh, an insight that the first component is e with power 3x, the second component is having e with power negative 3x. And in variation of parameters, we are going to find the Wronskian from these two particular functions. So we are going to check the Wronskian through the determinants. Okay, so determinant that we already learned in matrix, so it's also useful, and we need to also to check in the variation of parameters. So we are going to check the Wronskian. So this is the function, and the second row is this the derivative. And determinant will be equal to, you can check, multiply this. This is negative 3 because it will cancel, right? it is also cancel, and negative 3, so negative 6. Our Wronskian is negative 6. And then what we need to do next is we need to identify our W1 and W2. Okay, so we are going to exchange with 0 and f of x. So identify that, where is my f of x? Oh, here. So identify f of x as this. Okay. And then we need to check the W1 and W2. So W1, we need to change the first column with 0 and f of x. F of x is 9x. Let me write e like that. Okay. And the rest is just keep the same. So it will be minus completely 0 minus, right? 9x e negative 6x, right? And then W2, we are going to use the same Wronskian. And now the second column will be changed to 0 and 9x e negative 3x. And this will give 9x e, just 9x. Okay, 9x. Now, from here, we take the u1 prime as w1 divided by w. So negative 9x e negative 6x divided by negative 6. It will be 3 over 2x e negative 6x. Okay. And u2 prime is 9x, or let me write completely. w2 w 9x divided by negative 6, negative 3 over 2x. Okay, so this is the key. Finding this u1 prime and u2 prime. So u1 is integral of the 3 over 2 x e negative 6x dx, and u2 is integral of negative 3 over 2x dx. Okay, now integral this. I think we can use substitutions. So we are having negative 1 over 6, 3 over 2, integration. I think you can just use by parts, I think faster. Dix e 1, this will be negative 1 over 6 e negative 6x, and then 0, and one more time. Correct, right? Yeah. I think we can go and write the u1 is 3 over 2 multiply with negative 1 over 6x e negative 6x. This is plus minus plus. And then minus 1 over 36 e negative 6x. So u1 is negative 1 over 4 x e negative 6x, negative 1 over 24 e negative 6x. Okay, u1 is that, and u2 is simply we say negative 3 over 4 x squared. Okay, no need to add the constant because not useful for now, but we add later here in our solution. So general solution. So y c1e, let me write this one, the complementary. Okay, we write here again. The complementary is c13x plus c2e negative 3x. Since we have 1 over 4, 1 over 24, 3 over 4, I will factor out negative 1 over 4 x e. Oh, wait. I think we have oh, right. This is u1. Yeah, we need to. Okay, where is? So we need to multiply u1 and y1. So u1 y1. Forgot to multiply. So this will become. But we need to make sure that our y1 and y2 is correct. Okay, it's correct. Oh, no. y2 is the negative. Oh, yeah, it's correct. Okay. And then we add this u1, y1, v2, y2 into our component here. So we are going to have or we can factor out this is 1 plus 3x. And since this and this can be combined, so this is constant, so let's just write another constant, C3. Okay, this is the solution using this variation of parameters. So the idea is using the Wronskian from the function 1, function 2 here, and then we can have uh, Cramer's rule, okay, using Cramer's rule, solving the W1, W2, getting U1 prime, U2 prime, integrate that and multiply with Y1, Y2. Okay. Okay. Y2, Y1, Y2 is still here from here. So every time you check here, if we decide this to be Y1, Y2, okay? So this is Y1, Y2, Y1 prime, Y2 prime. If you maybe at the beginning different step, maybe you say that This is y1, this is y2. So you need to exchange all together. So you need to change, and the result will be the same. The result will be the same. As long as you take y1 and y2 consistently. Okay, as long as you take that two consistent, the result should be the same. Okay. It seems that this method, the variation of perimeters, is having more steps than the undetermined coefficient, right, from the previous one. So if you compare this with this is just having 2 or 3 steps, but the one that using long equation is precisely when you substitute into our dE. If you substitute the yp into dE, then you need to calculate the differential, and usually that's the takes the longer time. But here, all steps is short, but a lot of steps. Okay, a lot of steps. So if you want to choose, or if you are given options, choosing the previous method or the variation of parameters, it's up to you. It's up to you. Up to you. Okay.
Professor,
Yes.
I remember you said that some of the cases variation parameter can be solved, but it cannot be solved in undetermined coefficient.
Oh yeah.
In which case?
Some of the case is, remember, if you remember the table that I gave you. Wait a minute. Let me check the table. Let me go check the table. Oh, here. Okay, this is particular solution for some of the function. I'm right here. If you have this kind of functions on the right side, tangent, secant squared, secant x, tangent x, I think the best way to do it is variation of parameters. If you try to make using the undetermined coefficient, we don't really have our guess for what kind of solution that we can give. Okay? That's the condition. Okay? Look here, the form, if it's constant, okay, maybe just some constant. If you have linear, it's linear. If you have a polynomial, it's another polynomial. We have cube, it's cube. We have sine, always sine, cos, and sine. Cosine also the same, because they are interchangeable, right? They are having their periods, right? Sine, cosine, right? If you have e with power of 5 exponent, you have exponent with some constant. If you have multiplication, these two, then we have ax plus b and then exponent. And we have polynomials, and then we have exponent multiply altogether. When we have exponent and sine, as I said, we are going to multiply with our particular solution. And when we have 5x squared, it's a polynomial, it's a quadratic, then the polynomial and then cosine, and then the polynomial and then sine. Okay. And when we have 3 components, we have linear, exponent, and trigonometric. So linear, here linear, exponent, cosine. The other one, linear, exponent, cosine. Okay, so this is precisely what we have in the undetermined coefficient that we can predict with our yp. Okay, but in variational parameters, there are several functions that precisely we need to do the variation of parameters. So aside from all of that we mentioned in the table, then probably you need to use the variation of parameters. Okay, or actually, if you want to use just separation of parameters, that's still okay. It can be done in many cases. So in the questions that asking undetermined coefficient, you can use the variation of parameters as well. Okay. Okay. Any questions? Again, any questions?
Thank you, Prof.
Okay. Any questions again? Um,
Hello, Prof.
Mm-hmm.
Can you hear?
Yes.
Oh, uh, can we get the notes for this one?
Okay, okay. I will send the notes. Okay, in the Moodle
Oh,
late tonight.
yeah. And I want to ask like, if the variation this one parameters, is
Mm-hmm.
it like we'll get the same result as the page before?
Yes, should be the same result. Okay.
And
But
like if we miss if we miss some calculation and like will we get the same like point, but we get
yeah,
this
but
different answer.
a different point, but still give a point. Still have a point. So okay, that's why. One more important thing on your midterm. So I will give you a tips, okay, to get to optimize your points. First is let's just note that for midterm, remember that you need to have a paper, right? You have a paper. Please give your uh, beside your questions, give a number. Write question number, and then clearly write steps and answer. It doesn't need to be really clean as long as you write, like for example, you write equation here, you write equation here, and you write the answer here. As long as the equation okay, I can still give you some points. But if I cannot read which one is the steps, which one the number is, I think that will be very difficult because sometimes some numbers having same structure with the other numbers. So I don't really know whether this is the same, is the particular question or not. Okay, so that's one thing to remember. So please prepare a paper, and also besides I give you the notes about the table, I think it's also good if you write your own summary in the paper. So this is just my tips, okay? Just my tips. So my tips is first prepare uh, A4 summary because I believe every one of you have um, different take of notes, right? How you look at your course. Maybe you have different understanding. Although it's the same principle, but you can write with different with different perspective, right? So I think it's best if you write on your own, so that when you write, you can actually try to learn something. Okay, and when you prepare that as your notes, as your uh, A4 summary, I think it will be very useful in the midterm or in the exam. Okay, rather than using books. I think books very difficult to if you want to change the page, right? But just the summary. Okay? Books can be used if you go for more details. But if you just want to look on the summary, I think that will be very helpful for you. At least for me, it's really helpful. I think if you try to use that way, I think they'll be helpful. And also calculators. But I think calculators, not all questions can be verified, but sometimes it is really useful. And something is really useful, especially if you want to check whether your equation is correct or not. Okay, especially if your calculator can solve differential equation. That's helpful. Okay, that's helpful. And I don't mind if you're using it. I don't mind. Okay, but the point is what you write in the paper, it might give additional points. So please prepare very well. Okay, I check your quiz. Some of your answer it seems like not really structured really well. So I cannot give you many points. If you write like in a structured really really good, I can give you additional points. Okay, because it helped me to verify whether you understand the concept or whether you understand the question or not. Okay. So prepare A4 summary, calculator, okay, calculator, and then yeah, if you have textbook, you can also prepare textbooks. But textbooks, I think, not really that important, okay? Unless that you have. Okay. Okay, I think that's tips that I can give you. What else that we can have? I think yes, of course. In the midterm, you can use summary calculators. Okay, books if you have books. Okay, the only thing that I want from you is you work alone. You work individually. You can prepare in any way you want. Okay, you can prepare summary, maybe A4 summary. You can have like 2 paper, 3 paper. It's up to you. Up to you. Okay, is it clear? Is it clear? So you can prepare A4 summary. You can prepare 1, 2, 3, any papers you want. Okay. Okay, because I believe since we are having like too much content, so I don't mind. You can have your own your summary paper. Okay. Any other questions? Any other questions? If not, I think I will just stop until here. Okay, and I will give you this notes. At the same time as our schedule. Okay. So time. I think our time is 9:10, right? 9:10. So probably it will begin 9:15. Okay, we'll begin 9:15. So I think if you want to make sure you join maybe from 9 a.m. Okay, so that I can maybe give you some. Yeah, we can join WebEx. Okay, using the same WebEx first. So go for WebEx, and then I will give you the link at the spot. Okay. And if you have any problem with the technical, like in the platform, just let me know. Okay, you can just chat in the WebEx. Okay, is that clear, everyone? Okay, so time, just prepare from 9. Maybe we will start 9:15 for the exam. Maybe we'll take 2 hour 20-30 minutes, around that 2.5 hours, probably around that time. And I hope it's enough. It's sufficient. Okay. Okay, if there's no questions, I will end up until here. Okay, and see you on the midterm. Friday is Friday. No feedback from today class. I will just give you feedback later next week. Next week we will move matrix and the factor calculus, a little bit factor calculus. Okay, and then after that we will prepare a quiz and final exam. Okay. Okay. See you everyone. I will stop.